All right, so let's begin with problem 26 from KC9. 26, make a sketch of each function and identify the key features. Let's begin with letter A. Here we have an exponential function, 3 times 2 raised to the x plus 1. We need to first find the y-intercept. To find the y-intercept, we substitute x in for 0, or my bad, 0 in for x. We write 3 times 2 raised to the 0 plus 1. Put that in your calculator, and that will give you 4. So the y-intercept will be in a coordinate point of 0 for x, comma 4 for y. Your asymptote, since it's a exponential function, we have a horizontal asymptote. So that is denoted as y equals, and it's always going to be your k value. My k value in this point is 1. Since we have y equals and range represents my y values, that means that range will be affected based off the horizontal asymptote. So we do parentheses because we can never reach 1, comma, infinity. Domain for exponentials will always be negative infinity to infinity. Then, after all this information, we have to graph it. I'm given 0, 4 as a y-intercept. So right here will be 0, 4. We have a horizontal line at 1, represent the asymptote. My base is 2. 2 is bigger than 1, so therefore it's a growth function. So it's going to be increasing. And we just make a rough sketch. And that will be good enough for the final. Alright, B. This is a logarithmic function. For a logarithmic function, to find the x-intercept, we set the argument, which is x plus 3. We always have to set the argument equal to 1. Always 1. And we solve for x. So x is equal to negative 2. So the x-intercept is going to be located at negative 2, comma 0. Y will always be 0 if we're looking for the x-intercept. The asymptote for a logarithmic function is always going to be a vertical asymptote, and that's when we set the argument equal to 0. So when it's x plus 3 equal to 0, we solve for x equals negative 3. So we have a vertical asymptote at x equals negative 3. Since the vertical asymptote represents x, that means our domain is going to be affected because domain represents for x. It's going to be parentheses, negative 3, comma, infinity. My range will always be negative infinity to positive infinity. To graph it, we have an x-intercept at negative 2. So it's going to be x-intercept right here at negative 2. A vertical asymptote at negative 3. So a dashed line. And then after that, it's increasing. So we just make sure we go through it. And then we just go up. And that is how we do a rough sketch of logarithmic functions. I'm going to zoom out, see an overview for problem 26. And now we move on to the next problem, 27. So for 27, we're supposed to write each as a logarithmic function. If you recall, b of x is equal to y. If I want to change it to logarithmic function, you always write log and you write your base. Your base is the letter or the variable that is attached to the exponent. So in this case, it's b. B is the subscript, parentheses. From the base, you go around, making it y. So y goes inside the parentheses, is equal to, then you go back and solve for x. So to change the form for a, 4 is the base. So we write log 4, then we go around, which is y, is equal to, then we go back to x. B E is the base, so we write log base E of y is equal to x. However, there's a special rule when it comes to log of E. We could write this as natural log of y is equal to x instead. So these are your two changing the forms. 28. Solve the following equation. We have 3 raised to the 4x plus 2 is equal to 9x. For this type of problem, I recommend changing the bases for them to match. This will equal 3 squared raised to the x, because I know 3 squared is equal to 9, so I substitute in 3 squared in for the 9. When you have an exponent raised to an exponent like you have with the 2 and the x, that is written as 3 raised to the 4x plus 2 is equal to 3 raised to the 2 times x, which here is just 2x. Now that the bases are the same, we could forget about the bases and just focus on the exponents. Because of this equal sign, they have to be matching. So we set 4x plus 2 is equal to 2x. Subtract 2x to both sides and subtract 2 to both sides. The 2's will cancel. The negative 2x will cancel. 4 minus 2x will be 2x is equal to negative 2, because here we have a 0. Then we're left with 2x is equal to negative 2. To get x by itself, divide 2 to both sides. X comes out to be negative 1, resulting as your final answer. (29) Before you change it to form to log form, you have to get your base with the exponent alone. In this case, we have to add 5 to both sides, leaving us with e to the x plus 3 is equal to 17. Now that e is by itself, we change the form. Since it's specifically e, I'm going to just go along and use natural log instead. So e 17 is equal to, going back, x plus 3. We're solving for x, so we need to subtract 3 to both sides. So we have natural log of 17 minus 3 is equal to x. Then we just put this in the calculator and we get x is equal to negative 0.167. Final answer. Keep in mind, in the final, you could see the decimal answer or your exact answer. It all depends on the final. All right, 30. Solve the following equation. So we have log, just similar to the rule with e to the x or exponential function, you need to get log by itself. This is what it means to get the log function by itself. You need to be the log, the base, along with your argument. If that's all by itself and there's no additional properties happening, we could just automatically change the form. So I'm going to change the form to exponential form, making 4 the base. Then we go around, making 2 the exponent is equal to x minus 4. Solve for x. Well, I know 4 squared is 16. Is equal to x minus 4 plus 4 to both sides. So we get 20 is equal to x. (31) Solve the following equation. We have 3 times natural log of x is equal to 21. See how here your log isn't by itself because there's a coefficient of 3. Because of that, they're multiplying. To get rid of the 3, we have to divide it by 3 to both sides. The 3's will cancel, leaving you with natural log of x is equal to 7. Here I'm going to do a little extra steps. I know because it's natural log, I know that it's written as log e of x is equal to 7. Now I'm going to change the form, making it be your base, which is e, your 7 being your exponent, is equal to your argument, which is x. This could result as your answer. However, if the answer turns out to be a decimal, you'll have x is an approximate to 1096.63. So either one will suffice to be your answer. All right, 32. Solve the following equation. Log of x squared plus 8x is equal to log of 6x plus 8. In this case, since they're both log of the same base, since it's not being written, it means that log of base x, log of 10. Since they're equal to each other, that means the arguments also have to be the same. So we could just ignore the logs and just focus on the arguments, making it be x squared plus 8x is equal to 6x plus 8. And then we just solve for x. Subtract 6x, subtract 8 to both sides, leaving you with x squared plus 2x minus 8 is equal to 0. From here on out, we need to solve for x, we had to factor. So that leaves us with x plus 4 times x minus 2 is equal to 0. Set each factor equal to 0. So that we have x plus 4 equal to 0. X minus 2 equals 0. X has to be negative 4 and x has to be 2. When we're talking about logs, I make sure we're dealing with, oh, sorry, that was jumpy. When we're dealing with logs, make sure that the argument always has to be positive. So once you substitute x in for the argument, make sure it's remaining positive. So I'm going to substitute 2 in for x. You could pick either or. I'm going to use the 6x plus 8. I do 6 times 2 plus 8. That results in 20. So it turned out to be a positive number. Next, when I try negative 4, I have 6, negative 4, plus 8. That results into negative 12. Since it turned out to be negative 12, that means it's, wait, my bad, negative 16. Since it was negative 16, it was negative number, that means the argument is negative. That will lead to a domain error. Hence, negative 4 results in an extraneous solution. Which makes 2 your only solution. All right, 33. Suppose you deposit. Oh, well, I guess you restarted. Okay, going back. Okay, 33. Suppose you deposit $3,000 in a savings account that pays you 6.5 interest per year. Approximately, how many years will it take for your account to reach $10,000 using the formula A of t is equal to A times the quantity of 1 plus or minus r raised to the t? All right, so 3,000 represents your initial amount, so that will equal 3,000 times 1. Since we put it in a savings account, that means we're gaining interest, so we're going to do plus. We need to put 6.5 as a rate in decimal form, so it'll be 0.065 raised to the t. We want to get $10,000 in the end, so that will be my final amount. So this will be the setup. We need to get your base and the exponent by itself. So we need to divide both sides by 3000. This results into 10 over 3. I'd rather keep it in fraction form. Is equal to 1 plus 0.065 will be 1.065 raised to the t. Now that the base is by itself, I'm going to change the form to log base 1.065 of 10 over 3 is equal to t. Put that in the calculator and you get your time will be roughly 19.12 years.